So hello and welcome to today's MTD podcast. This is the first one I've hosted actually for a while, and I'm quite excited to do so. I feel privileged actually with a guest that we're going to be welcoming on today's show because it's Kasra Mehraky. We've spoken with him on a couple of occasions before. In fact, I did a live feed with Kasra going back. It must have been about 4 or 5 months ago now when we were in the depths of lockdown here in the UK. It looks like we're kind of almost heading back that way as well, which is a real shame. Hopefully that won't be the course of events in the coming weeks. But Kasra is a machine tool consultant. He works with machine users around Europe in assisting them in selecting the correct machine for the right application. So Kasra is going to be joining us shortly. Kasra, hello and welcome to the podcast.
Hi, Paul. It's very
Good
nice
to
to hear you.
Yeah,
Yeah.
good to hear from you and good for you to be on today. Thanks for coming on. I'm also with Gio here in the studio, Giovanni, who's obviously a big fan of Kasra's as well. I know there's been a previous podcast which you can actually go to our channels and find where this couple have actually discussed machine tool applications in the past, I believe, Gio, haven't you?
Yeah, absolutely. Hi, Kasra. Hi, Paul. Thanks for having me on this podcast. Really looking forward to it.
Good. Now, the theme of today's podcast is quite an interesting one, and it's something that actually, and I often talk about reminiscing about machines I've sold in the past in my history of selling machine tools, but I have been involved in selling the types of machines that we're talking about. We're going to be talking about big milling machines, very big milling machines, portal machines, gantry machines, but really the real thrust of this is for, if you're listening, for users to make sure that they select the correct machine for the correct application when it comes to a big milling machine. So firstly, Kasra, I think we'll start with you on this. Maybe you could give us maybe a very quick overview of your experience in this area and how important it is to make sure you do pick the right machine.
Um, sure, Paul. So I started working in machine tools business. I think it's been now 10 years. And I started in manufacturing machines, and also our company, we have been involved with a few designing and making gigantic, actually, portal milling machines. So I think this is a crucial thing that you mentioned, that people, when they want to purchase a new machine, they should definitely and absolutely be sure which kind of machine is the best option for them, because when we are talking about big machines, there are quite a few options in the market, and it's absolutely essential that people completely understand their application and the kind of machine that is needed for them.
Yeah, I mean, we talk about milling machines here, but of course, a lot of what we're going to talk about today also incorporates turning as well, because these machines have become very much multitaskers in recent years. We're going to be talking about small size portals. We're going to be talking about medium sized portal machines, large portal machines, also the kinematics, the heads on the machines, and getting a real idea of where the right machine is for the right style of application. We'll also be talking about some of the brands that are available in these differing categories. Now, let's maybe start with the smaller machines, Kasra, because you've listed here. So we've got some notes. We're talking about you divide the machines into three groups: the small sizes, such as maybe a Hermle, a Hedelius, a DMG Mori. Maybe you could give us an idea of what you class as a small portal machine.
Absolutely, yep. So normally, when I want to categorize portal machines, I divide them in three different groups. So for small sizes, as you mentioned, we have machines that are mostly used in automotive industries or aerospace industries, and they're processing materials such as titanium or aluminium, sometimes also hardened steel. But these machines are roughly between a working, I'm talking about a working envelope about 500 meters to at the most 500 millimeters to at most 1 meter cube. So these are categorized in the smaller types of portal machines, and they are super fast. They are mostly with the table kinematics. So you have 3 axis gantry working on the top of a 2 axis Turnian table. And well, these machines, I mean, the best ones that you mentioned in the market are such as Hermle or Edel or Hedilius, which are mostly German brands, and they are used in many different applications. Um, but I think the biggest sector is aerospace for them.
Okay, let me just ask you a question. I know Gio's got plenty that I'm sure he wants to chip in with as well here. Often, quite a common question to us is, what's the difference between a portal, a gantry, and a bridge type milling machine? Could you maybe summarise?
Yeah, sure. So basically, we are talking about the same thing, but different companies refer to them a little bit differently. For Portal and Gantry are basically the same thing, but the bridge type is normally when the bridge is fixed and the table is moving underneath. So you have 2 axes on the bridge, you have the z-axis and the y-axis, and sometimes even the bridge itself goes up and down, and you have another additional axis called w-axis normally, and then the x-axis goes underneath the bridge, so it would be a fixed bridge and or fixed gantry. And for normally for portal machines, we are talking about the moving gantry. So all the axes are on the gantry. So you have X, Y, and Z all moving on the gantry. And if there's a table involved, then that would be underneath the gantry. Or sometimes it has a head, so it would be 1 or 2 axes on the head, and 1 or 2 axes on the table.
I don't want to go too much off topic really, but when I listen to that, one of the things I think is if that table's moving, that that takes a lot of force to move a bed like that. Surely you're better off with a fixed bed, aren't you? And all the work being done on the gantry.
Well, it's a tough call, but it used to be in the past. Yeah. So in the past, most of the machines, the gantry machines, were using a moving table, and they were assuming that it has more rigidity, but in the recent years it needs a lot of, as you mentioned, a lot of force, and then of course the workpiece is on the table itself, so it is quite a huge amount of mass moving all the time, and these days we are focusing on machines that are working faster. So instead of having a bigger tools that they can grab bigger bytes from the workpiece, we try to go much faster, and that would also help with the tool life, and it would increase it enormously. So as you said, a lighter gantry these days is more appreciated.
So, Kasra, great to talk to you again. So, with your role as a consultant in this kind of area, we always talk about application specific requirements at MTD, and that goes across all kind of machines, really, but even more so in these type of machines that we're discussing today in this podcast. Starting with the small size portals, you mentioned they lend themselves specifically or predominantly to aerospace. Why is this?
Well, you have to look at the parts geo that they are used to cut. So normally, for aerospace, you have, for example, different kinds of jet engine parts that needs to be machined precisely. And when we are talking about jet engine parts, or all different kinds of parts that are used in airplane, or for example satellite housings, they are roughly not very gigantic, not very big. So normally they can be fit in a 1 meter envelope. and that's why these companies such as Hermley are mostly focused in these kind of machines, or also another good Italian company called Breton. So these are mostly focused in these kinds of machines, and they've actually done a very good job because they are specialized in small size gantries.
Just out of interest as well, Kasra, what's the we look at your we're talking specifically really here about the builds of these machines and making sure you select the right one for the right part. I 100% get all that. Where, in your opinion, though, does the CAD CAM element come into this? Because we look at some of these machines and the agility of them, and some of the parts you're talking about, the aerospace sector with the blade machining. It's important to have the right machine, of course, with this construction. But the software that's going to be driving these machines around has to be at its optimum skill set as well, doesn't it? In order to maybe reduce some of those wear elements that you might get on a machine by improving the profile of the machining or the path that the machining takes. Is that quite important in this in the strategy of selection as well?
Absolutely, yeah. So well, there are not many software developers out there in the market. So basically, we've got Siemens and Autodesk and SolidCam and just a few softwares. But it is very important that the programmer is completely uh, expert in what he's doing. So there are different kinds of strategies and different kinds of approaches, and he needs a lot of experience in machining and also in programming to be able to use the most efficient strategy to machine a part.
So, Kasra, you go and visit a customer that's making an aerospace component. How do you determine, what questions do you ask to determine the best machine tool for his application?
Well, basically, we start normally with the part that they are doing right now, or they are planning to machine in the future. So there are various different factors that needed to be considered. For example, one of them is the material of the machine, and the other factor is the number of pieces that they want to produce. So with these two in mind, then we will look at the speeds of the machine that is needed for manufacturing, or the number of the machines that are needed. And then you need to, when you have a conclusion about all the technicals, then you have to also add the financial um, points of view to see which kind of machine from which vendor is fitted for this specific customer.
I want to coming up as well. I should mention that we're going to be talking about more medium-sized portals shortly and large-sized portals, and the combination of using five-axis heads on these machines, as well as the turning element. So lots to come in this podcast. Just coming, I can't help but keep going into this one, Kazra, because I'm really interested in your opinion on this. You're talking about very high end machines here. You've mentioned the brands. I've sold some of them and spoken to companies that use them. But there is this argument that keeps cropping up in our industry about actually investing in potentially a lower cost machine with slightly less technology in the hardware, but investing more in the software, in the tooling, in the work holding, and all of the accessory elements to get and achieve the same result for less money. Do you think is that possible, or is that just someone that sells lower cost machines wanting to find a way of selling them?
Well, definitely it is, but you have to be very careful when you are looking at lower cost machines. Actually, I have a customer in the UK who's been using very well known American machine tool, a five-axis machine, and they had maybe five or six of them. And when once he asked me that, how often do I need to change the spindles on a machine, and I I didn't even comprehend this question. I said spindles, and he said, yeah, we roughly change 2 spindles per machine every year. Uh,
What?
yeah,
Jeepers creep.
so these machines are working 24/7, 5 axis, and they normally change a trunnion table every 2 years and 2 spindles per year. So
Wow.
when you're looking at these numbers, then you see that there's absolutely something wrong with this business model. So these are the things that we have to be very careful when we are going to invest on a machine tool. And there's some
However,
solutions.
Kasra, that takes us back to the beginning, really, application specific. Them particular machine tools would have been perfect for a different application and most probably are being used for the wrong application.
Definitely, yeah, absolutely. So this customer replaced all those 5 machines with just one machine that we suggested, and it's been working again 24/7 with the same yield. So the number of the production is the same. So just one machine replaced 5 machines, and the spindle of this machine tool manufacturer is guaranteed for 10 years, 24/7 working. Uh,
Okay, let's get into the nitty gritty then in a bit more detail, because this is a topic that's really close to my heart and something we do regularly discuss while out with machine tool manufacturers and distributors. What are the elements of a machine that you believe make a low cost machine different to one that maybe is going to do what you're suggesting, last the test of time? There's one area that one machine tool manufacturer mentions to us. It's about how they stack all the axes in order to make sure that the vibrations dampened out, but also to make sure there's less stress and less wear on the moving parts. Would you agree with that firstly? And what other areas do you think are important in building a machine that's gonna last?
Well, this is actually an amazing subject that because I come from a machine manufacturing background, and I've been dealing this for like 10 years. I've been in the same. I've been facing the same problems every day. Well, for example, when you look at some designs, for example, from Hermle, they're absolutely brilliant. And you can compare it to a normal machine manufacturer, and you see the amount of linear guideways, the amount of blocks or carriages, and the mass of the machine, the weight of the machine. They're all the same, but there are only a few touches and a few details different in these two machines. So they are both these two manufacturers are spending the same amount of money to manufacture these machines. But because of those excellent designs, one would be Hermle, and the other one would be a very low end a machine that you can find it everywhere, and it loses value. Loses its value in maybe like less than 2 or 3 years.
Kasra, just before Paul's got his next question, but isn't there an argument to say if you buy a machine that has got longevity for 10 years, that maybe even in just 5 years' time, technology moves on. And in 10 years' time, that machine is going to be completely out of date and out of sync in regards to new technologies that have emerged.
Well, that's also a true statement. But in machining industry, so far I haven't seen big changes in a short amount of time. So you can see, for example, let's talk about controllers. So we have the latest model of Heidenhain, which is TNC 640, and it has been around for like I think 15 years now, and of course it has some updates and better screen, also maybe higher speeds. But in general, when you're comparing a machine, for example, from DMG Mori from 8 years ago, and a machine from today, maybe it's like 20% more efficient. So it's not a very big gap between a 10-year-old machine and a brand new machine. Of course, it is going to lose its accuracy, and it's going to lose some new software features that they are not supported anymore. But in general, a good machine tool life expectancy is between 10 to 15 years.
Yeah, I mean, we're going to move on to medium-sized portals now, Kasra, and a lot of the topics that we're discussing apply across the board of these machines. So we'll keep you on your toes throughout, I promise. But some fascinating answers so far. So so medium-sized portals. Then this is when we move into the next dimension. Really, what do you class as a medium-sized machine in its axis, stroke, and movement?
Well, for a medium-sized portal, I normally talk about space between columns, or the uh, the uh, the columns that the gantry is on them. So normally starts from 2 meters wide, and the length, of course, can be uh, different. So it can be 2 or 3 meters up to 30 meters. So, but normally the key factor is the width of the machine, which starts from roughly 2 meters, and it goes up to maybe 3.5 meters. And there are so many machine manufacturers in that area. I would like to name some of them, like Zimmermann in Germany, or SHW also in Germany, and DMG Mori also has a very good line of, as they call it, XXL machines that they produce these medium-sized portals. And we have some Spanish manufacturers in that area, such as Zaya and Korea and Suraluce. And of course, there are very good Italian brands such as Fidia, Breton, FPT, and Papus.
We've actually been to a couple of the factories of the machines you mentioned, FPT and Korea and DMG Mori, and we've been privileged to actually visit their factories and see the machines being built. There's a lot of the things we spoke about on the small portals, build quality, construction, speed, they all apply across the board. But one that I think becomes more important the bigger the machines you get, is how you maintain accuracy over bigger distances. Now, out of interest, I'd be again intrigued to know how you think machine tool builders achieve this, and what's the best way to do it. But there's one particular brand here, Gruppo Parpus, where I remember going to a company that had one of these machines, and in fact, it was probably a large size portal. But they had one of these things. I think it was called like an air curtain or something in the sides of the machines, which kept the area of the machine cool, which meant that there was minimal growth, which meant that even if you had one of these big dies that was 2 meters by 3 meters from corner to corner, you were guaranteed certain accuracies. Is this an important factor as the bigger the machine gets?
Absolutely. I think this is the biggest challenge that you mentioned, Paul. So once we designed the gantry, it was about 8 meters long, the gantry itself. And we calculated the growth of the machine during day and night. It was roughly about 0.5 millimeters. And the allowance, the clearance that we had was in the blocks of the linear guideways. I mean, it was something maybe less than 0.01 millimeters, something like that. So we had 50 times more movement of the gantry itself during day and night. So this is a crucial challenge that we need to face. So normally these machines are always cooled or stabilized in a certain temperature by using coolant running all through all the different parts of the machine, and tries to keeps it at the same temperature at all times. And this also, it is more noticeable when the machine is working. So all the heat that the motors, the servos, also the cutting is producing, can cause to expansion of the different parts of the machine. So it's very challenging actually when the machine gets bigger and bigger, this challenge becomes more noticeable.
What's the most accurate machine you've worked on or with over a big working envelope?
Well, there are two machine manufacturers which are absolutely excellent. One is Waldrich Coburg in Germany, and the other one is Pietro Carnaghi in Italy. So they are mostly categorized in the large size portals. So we are talking about maybe 500 tons of table load and maybe 14 meters between columns. But these machines are in a short and small size working. They can provide maybe 5 microns of accuracy, which is absolutely brilliant for that kind of size of the machine. Of course, they don't use linear guideways; they are all using hydrostatics. But for that kind of gigantic machines, this accuracy of 5 or 6 microns is absolutely amazing.
So, Kasra, with such a large range in the medium-sized portals, and for you to kind of pick a machine tool specific for an application, what big differences are there between these different machine tools, which will um, govern your selection process? Apart from the accuracy, maybe,
Right? Yeah.
obviously you just mentioned accuracy.
Yeah.
Is it speed, programming?
Well, normally it's good now that most of these machine manufacturers are using same kind of controllers. So, for example, if you're going for a 5-axis machine, they are mostly offered in either Heidenhain or Siemens. So, in terms of controls, you don't have many other options. Sometimes for Okuma, you might get Fanuc, but normally it's Siemens or Heidenhain. Uh,
Why is that, right?
Okuma?
No, no. Why is the programming
Oh,
selection
right.
reduced when you go into the larger size machines? Is there any reason for that?
Uh, Not really, but because these two companies, I mean Siemens and Heidenhain, they are mostly experts, considered experts in this area. That's why they are chosen more. I mean, there's Fidia, of course, that they produce their own controllers, which is absolutely good, and I've been using it maybe from 15 years ago. But in general, this is people always go for Heidenhain and Siemens.
What about the new Fanuc control?
Yeah, 31, you
That,
mean?
I'm not sure which models, but I know one of the. I know we've been looking at a few machines recently that are
Yeah,
incorporating. Mind you, we're talking about a different machine type. If
yeah.
in
To be
fairness,
honest, I haven't seen Fanuc controls on many portals. Uh, Normally, it's either Siemens if they want a lot. If the machine has a lot of axes or additional axes, they always go for Siemens because Fanuc doesn't support that many axes. I think on the 31 we can connect maybe 24 axes, which is 6 axes simultaneous. But on Siemens we can connect up to 96 axes.
wow. Okay. So before we move on to the large size portals, and I know again, as I say, some of these topics cover all of these machines, but the sort of applications that fit into the medium size, then, Kasra, we mentioned aerospace in the small size portals, the medical sector, maybe. What fits in amongst on these machines?
Well, for medium-sized portals, normally my customers are working in the automotive industry because they are very useful for making dies and also in industries such as when they want to produce big molds for different kinds of different parts of automobiles. I think. The medium-sized portals are mostly used in automotive industry.
No, that's really interesting, really, Kasra. And going back to my previous question, then, Kasra, the programming seems to be around the capabilities, really. You know, the programming language seems to be determined by the capabilities of the machine tools with the different axes that they're looking to run. So picking or choosing the right machine tool for the application, what kind of USPs do these different machine tool providers have, that you would kind of select one rather than another?
Yeah, it's a very good question. So, for example, some of these, when we are talking about five-axis machine, some of these manufacturers, because a very important part in a five-axis machine is the milling head. So, some of these manufacturers they produce their own milling heads, such as Siemens and or Fidia, and some others they try to buy milling heads from some companies that are very well known to just producing milling heads. Of course, that makes a little bit difference because a company that is dedicated to manufacture milling heads and spindles is more capable in building a better head. And the head, the milling head, is the heart of the five-axis machine, so it has to be absolutely well designed. For example, there's a German company called if I can find their name. There's an Italian company called Techni, which they produce milling heads, and most of the Taiwanese companies and Chinese companies they are using Techni milling heads, even though Chinese and Taiwan, especially Chinese, are mostly well known for producing cost-effective machines and low-cost machines, but they are buying the head from an Italian company because it is such an important part of the machine.
I mean, there is so many aspects to it, isn't there, Kasra? I hear the things you're saying. We talk about accuracy, the spindle, the build. Often people talk about the weight of machine, and then you think, well, there are so many factors in how you select, and that comes across very clearly in what you're saying. I want to move on to the large size portals now. Some of the brands you've already mentioned, Waldridge, Coburg. I've actually used one of those machines when I came out of my apprenticeship. And in fact, it's interesting that you mention about them being one of the companies that produces a top quality product. I can only but agree with that because I used one of these machines and it must have been 20 to 30 years old when I used it. And we still used to use it for line boring. We used to use it for some of the most high tolerance machining on engine casings and things like that. And it used to hold tolerance. Never, hardly ever broke down. And I'm sure you'll give us some of the reasons behind that, maybe. But we talk about Unisign, Soraluci, FPT, Pietra Carnegie, as you've mentioned, Palmer. I've used a Palmer as well, yeah. SHW, Akuma, Ingersoll, DMG Mori, Droop and Ryan. The list seems to get longer as we go up in size. Is there a reason for that, or is that just we've missed brands off of the smaller ones, or are we just looking at the quality machines? But the bigger the machines, the more quality machines there are.
I don't think so. Maybe I didn't put many names in the medium size, I think.
Okay.
But I'm absolutely sure that I've listed all the large size manufacturers. I don't think that maybe I didn't mention a couple, but I've mentioned definitely most of them. So in large size machines, we have very very good options to go for. When we are talking about a very very gigantic ones, there are only two options. That would be Waldridge Coburg and Pietro Carnegie, and maybe after that Inseberardi. So these three vendors, the first one is German, the second and third one are Italian. So these three are, I mean, they are making enormous machines. We are talking about, as I mentioned, maybe 14 meters or 12 meters distance between columns, and maybe 30 to 40 meters length of the machine. And they always have a moving bridge on their gantry. So, for example, you have 6 meters stroke for the bridge, and then a couple meters on the z-axis ram itself. So it would be maybe 8 meters of total stroke in the z-axis. So these machines are enormous, and you can put a workpiece maybe up to 500 tons on a very big Pietro Carnegie. And Pietro Carnegies are normally turning and milling machines. And also the same thing for Waldrich Coburg. And these machines are so accurate that you can also do some grinding processes after machining. So after these machines, we move on to a little bit smaller ones, such as Parma or SHW or Ingersoll, Soraluce. And again, FPT has a line for large portals. And I've actually been to, for example, a few of these machine manufacturers. In Parma, there are Pietro Carnegies that are producing Parma machines. So you can imagine that those gigantic machines are being machined in a Pietro Carnegie.
I mean, Kasra, I mean, for me personally, these machines are a engineering masterpiece because they don't come in one piece, do they, Kasra? You know, to give our listeners some kind of idea of how these
They all
machines
seem to be built in Europe as well.
It's amazing. It's amazing. I mean, I went to one installation when I was back in the day selling work holding up in Newcastle, an aerospace company, where they had to dig out the foundations where this machine had to go into. And to have that kind of accuracy over that distance, but the pieces in which it's like putting a jigsaw puzzle together, but then the flatness and the parallelism of the machine bed for where the bridge runs over, it's a feat in itself putting that machine tool together. Can you kind of give the listeners a bit of an indication to what it entails to put a machine tool like that together and the kind of the process involved?
Well, I have a good example for that because one of the biggest portals that I make, I was the chief designer of a project, and it was, I think, 18 meters by 6 meters, and the z-axis was about 2.5 meters a stroke. And I think it took about 14 months from us to design this machine, and maybe a year and a half to manufacture it. And there are absolutely so many parameters that needs to be considered, such as even logistics, how to move these machines, how to move the parts, and how to assemble them. You need a lot of different kinds of sensors, a lot of different measurement tools, calibration tools, and of course, I mentioned the thermal conductivity, which can cause expansion. So you need to stabilize the temperature of the place that are you assembling the machine. So there are so many parameters that needs to be considered while even putting the work pieces on a bigger machine to machine them. So there are
Can you say what the machine was that you were involved in, Kasra?
yes, I was involved in a project. Yeah.
Yeah. What was the machine brand though? What was it?
It was our own company back in Iran. 01 CNC was the name of our company.
Okay. And what was the machine actually making?
Well, this was mostly for oil and gas industry. So it was manufacturing very big valves and machining big valves. Yep.
Okay.
No, I think that it kind of you've really kind of set the scene there in regards to kind of illustrating what it actually entails. It's not like just buying a standalone machine with a few bits. It takes it to a completely different playing field, and like I mentioned, it's the work involved. 1.5 year project to actually even just get the machine installed is just. It's phenomenal, really, isn't it?
I mean, one brand that's not mentioned here in the large size, but is in the medium size, and I do think fits into the large size as well, is the Courier. there is some courier machines that I've seen, and one point that they try to put across as a very strong reason of their machine's machining capability, which is what this all boils down to at the end of the day, isn't it? The ability to machine reliably, accurately, but over long periods of time, is the box construction in their RAM, and how they keep it cool as well. That's one of the areas that they see as quite significant in the head technology, which kind of leads us on to really the kind of next and possibly final topic for this podcast. The RAMs, the heads, the changing of the heads, how you maintain positional accuracy when you're indexing the head. These have to be, in my opinion, these are as important as anything else on the machine, aren't they?
Absolutely, yeah. For example, there's a company called Unisign in the Netherlands, and another one in Spain called Bose. These two produce hexagon type RAMs because I believe that it actually helps the rigidity of the RAM, because we are talking about maybe 2 meters stroke of the RAM, which is maybe 400 by 400 millimeters, the size of the RAM, or maybe 500 by 500, and it needs to transfer the power for the spindle. Sometimes on Pietro Carnegie machines, it can be up to 10,000 Newton meters of power. The machine that we built was 2,200 Newton meters of spindle power, which is absolutely enormous. So this design of the RAM is very important, and that's why I've mentioned that it is really crucial that we completely understand the application that the user is needs the machine for, because
It's
these
it's
different
really
machines they are completely of course in the big picture they're all the same, but when you go into the details, they are each one of them is good for one application.
the hexagon you're talking about there. I actually saw this for the first time on I think it was on a DMG machine, on one of their very small, what we would class here as a small portal. And I looked at it and I thought, hexagon, and then I kind of I can understand the mechanics of it, and I look at it and go, yeah, I can see why they've done that, because you've got more mating surfaces rather than just four. It just seems a much more stable way of keeping things in alignment, really.
Definitely. And when you think about that, they need to make that RAM, that hexagon RAM, completely uh, grinded in a perfect way, because all these 6 or 8 surfaces are in contact with a hydrostatic guide wave, which is very, very hard to produce. I've never done a portal machine with hydrostatic, but I've been to some companies, and uh, just to look at the way that they're producing these hydrostatic guideways is absolutely mind blowing.
Catherine, like it is mind blowing what we're talking about now, and the design and the application, and making it a reality. Really, when you're talking about these RAMs, what's the longest the RAM can stick out?
Well, the biggest ones that I've seen is 2.5 meters, so 2.5 meters. I think that would be the limit of the RAM, and the RAM itself, it would be maybe 600 by 600 box and 2.5 meter sticking out. But that's of
And
course for a vertical RAM. For a horizontal RAM, it would be much smaller, maybe 1.5 meter, 1.8 meters, something like that.
and when the RAM is sticking out to its full length, what kind of inertia issues would you incur, or are they completely alleviated by this hexagon design?
Well, of course, it when you're sticking the RAM that much out, some things like chatter, they're likely to happen, and that's why these machines are using a moving bridge, so that can support the RAM. For example, when you want to stick out the RAM further on, and the workpiece is not very hollow, so you try to lower down the bridge and keep the RAM supported by the y-axis as much as you can. But there are some parts that you need to, because the bridge, of course, is very big, and you want to access a very hollow area in a very deep groove or something, and then you need to stick out the RAM. But then, of course, you can't machine that with the highest force of, as I mentioned, like 10,000 newton meters or something. So that would cause a lot of chattering, and also maybe the tool will be damaged. So these machines they have sensors to detect the amount of chatter, and of course, with jerk control on the controllers, it can manage to compensate that things that are happening. But some companies, such as Soroluce, they have added uh, a new vibration electromechanical vibration device on the RAM, and when it starts to chatter, it all automatically detects that vibration frequency, and that vibration electromechanical device generates a reverse wave on the RAM to remove this kind of chattering.
I mean, it's always a point in life throughout that you're only as good as your weakest link. With a lot of these machines using not just tool changing technology, but head changing technology, is it, if you're making the strongest and the most stable construction, yet you're trying to then change the heads on the RAM, is that not a point of sort of contention that you may be bringing into the machining process some weaknesses? Or how's that addressed?
Well, there are always some challenges. For example, because these machines are multi-purpose machines, we are talking about millions of euros, of course. So, for example, when you're investing on a machine with maybe 10 meters between columns, so you're thinking to machine everything that comes through the doors of your workshop or your company. So this machine needs to be able to do some turning, vertical turning, and also milling, three-axis milling, horizontal milling, also vertical milling, and five-axis capability as well. So when we are talking about different heads, of course, there needs to be some heads dedicated only for turning applications, and for turning the forces that are applied to the RAM is much higher than the forces, for example, that are applied to the RAM when you are using a milling tool or a five-axis head. So these all needs to be considered when designing these machines.
Okay, now we're going to move on to our final point now for this podcast, Kasra, about the integration of turning into some of these machines. You mentioned a particular brand, Asquith Butler, which I know you wanted to talk about, one of the only manufacturers that machines a specific machine, which I'm sure you'll tell us all about. But it is commonplace these days to be able to have a machine and then have this turning function within it. I mean, it's so handy, and that's probably an underestimation as a use of a word. But to be able to have that turning ability in a big portal machine, because it means you don't have to transfer the part to a big horizontal lathe or a vertical lathe. You know, there's less work in progress. It's all done on one machine. Um, is there any disadvantage to that, other than the obvious one, I suppose, which would be cost, because they must be expensive, these machines?
Absolutely. So of course there would be disadvantages, as you mentioned, when we are talking about a machine that is dedicated for one purpose only. That would be, for example, a vertical lathe. That machine is designed to handle all the tools for turning only, and also the machine table. It normally doesn't need to be very accurate in terms of positioning. So, but on a milling machine, on a portal milling machine, we need that table to be uh, as fast as a lathe and also as accurate as a milling machine. So these two normally cannot be mixed together. we can somehow compromise these two together. For example, we can say a vertical lathe can rotate maybe roughly for a 4 or 5 meter diameter table can be maybe 200-300 RPMs, and the same thing on a portal milling machine maybe can be 150 RPMs. So we are losing maybe like 20 or 30% speed on the rotation of the table. But this table is also capable of very accurate positioning, because we need that thing to be able to mill our parts afterwards.
Well, I suppose that when you're talking about machines of this size, the table doesn't need to spin at the same rotational speed as when you're doing smaller components. So that does make sense. Kasra, I just want to touch on one last subject, really, and the kinematics on these machines and the different types of kinematics for different types of applications. You mentioned a few. Can you tell our audience what this means and how it affects the application?
Absolutely. So it all depends on the workpiece size. So, for example, if the workpiece is roughly small, relatively small, we normally try to put that on a rotating table. But when the workpiece starts to getting bigger, then we try to fix it on the table and then move the head around it. So when we are talking about a 5-axis machine, if it fits in the small size category that we mentioned, most of those machines are table machines. So you have a trunnion table underneath the gantry, so you can put the workpiece on the table, and it can do all the rotating and all the different angles that you need to access with the spindle. But then when the machine, when the workpiece starts to grow, then we will move to different kinds of kinematics, such as head table and head. There would be the 2 or 3 two axes on the head, and then maybe another additional axis at table underneath the gantry.
That's a really good, probably a great way to end this, because it just shows that your knowledge in how you select a machine in accordance with the application, which really, hopefully, for those that have listened, that's what we've spoken a lot about in today's show. But in addition to that, we've obviously covered a lot of the machine technologies. We've even spoken about a lot of the brands that are falling under the umbrellas of these portal machines. It is a topic that really we could talk for hours on this. But I'm sure the people that are walking their dogs at the moment are almost home, so they probably need to cut us off. So we're going to wrap this podcast up now, Kasra. I just want to say thank you very much for being part of this today. You're a very skilled individual. You've got a lot of good. We've spoken to a lot of people that have used you in the past, and I think we're reaching out to engineers out there. If you are looking for someone to talk to you and guide you in your machine tool selection purchase, then Kasra Mehraky is definitely an option, and you can find details of him. We'll make sure we put them on wherever we put this podcast, so you'll be able to contact him. There is an interesting feature coming up in our magazine in January, I believe, Kasra, which is going to be focusing in on a lot of what we talked about today. Is that right?
Yeah, definitely. On the January issue, I think there will be a paper about also portal milling machines. So that would be an interesting subject for your readers, I believe. I hope.
So if you'd rather read than listen to us, then there is that opportunity as well. And I'm sure there'll be some golden nuggets in that article as well. Kasra, thank you very much for joining us today. This has been a great podcast. Gio, thank you for coming along as well. I think it's been a thoroughly engaging session, hence the reason it's gone on a little longer than most of our podcasts, but certainly the place to learn with gentlemen like Kasra. Thanks for joining us. That's it for today's MTD podcast.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.